Now in this video I want to show you how to compare the percent dissociation of the acid in the previous example and the percent dissociation of the acid in buffer solution. So in part A, when we were dealing with acid for the previous example, we had 0.1 molar HC3H5O2. The percent dissociation, it was concentration of proton divided by concentration of original acid times 100%. The H plus concentration or proton concentration in previous example, it was 1.1 times 10 to the power of negative 3 divided by the initial concentration, which is 0.1 times 100. That's gonna give me 1.1%. Now let's check the percent dissociation of acids in buffer solution, which we have 0.1 molar of the acid and 0.1 molar of the base. So the formula is going to be exactly the same thing. In this case, the proton concentration was 1.3 times 10 to the power of negative 5. 1.3 times 10 to the power of negative 5 divided by initial concentration, which is 0.1 times 100. In this case, it's going to be 1.3 times 10 to the power of negative 2%. So as you see here in conjugate acid, when we have the buffer solution, we have much lower percent dissociation. Why? If I want to write the equation, plus the conjugate acid. In the second case, we have this one, and it's going to act as a common ion. So we have common ion effects, and the presence of this conjugate base of the weak acid inhibits the acid dissociation. So that's why the acid dissociation reduced significantly from 1.1% to 1.3 times 10 to the power of negative 2%.